Hi guys, today we're going to talk about scientific notation, and the I can statement we're working on is I can write a number in scientific notation. And I put down using a whole number times the power of 10. It's really not going to be a whole number, but you'll see that the number that we're multiplying by the power of 10, 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, and so on, is actually going to have to be written in a specific way. Scientific notation can be best summarized by saying you're writing numbers that are really, really big or really, really small. So I want you to pause the video, take a few seconds, work all these ones out mentally. You can do that. It shouldn't take you too long. And then underneath that, I want you to write an observation or two that you've made about the relationship between your first factor and the power of 10 that you are multiplying by. Okay, let's check your work. Number 1, you should have gotten 25. Number 2, you should have gotten 350. Number 3, 6,700. Number 4, 84,000. Number 5, 680,000. And number 6, 4,200,000. You may have noticed that the number of zeros in your power of 10 are represented by the number of times you had to move your decimal to the right, and you would be correct. So mathematicians and scientists often work with numbers that are extremely large or that are extremely small, and so it can be really annoying and just take a lot of time to write out these numbers time and time again. So you might also have noticed that a calculator, this makes it a little challenging to do too, is that a calculator can only fit about 10 digits on a screen, your average calculator. So scientists had to come up with a way, and mathematicians had to come up with a way to write these really big or really small numbers in a way that we're not writing out hundreds of zeros or digits in a number. So let's look at for example, the planet Pluto, which isn't really a planet. Sometimes it is. Currently it's not. But let's say Pluto is 2,670,000,000 miles away from Earth. And you may not want to write out all those zeros every time. So what we could do is write it in scientific notation. So we would take this number and we'd abbreviate it to look like this, 2.67 times 10 to the 9th. Now pause the video for a second and make some observations. How do you think we got from 2,670,000,000 to 2.67 times 10 to the 9th? When you're done writing your observation, let's go on and see if you're right. Scientific notation works by rewriting numbers as the product, means we're multiplying, of a number times 10 to a certain power, and that number has to be written in a specific way, as I mentioned earlier. So let's take 45 million. In scientific notation, that would be 4.5 times 10 to the 7th. You might have noticed that there is only one digit in front of the decimal point in the few examples the 2 examples so far that we've looked at. This is because when you write the first number, the first factor in scientific notation, it always has to be written as a number greater than 1 but less than 10. And if that's the case, you're always going to have only one digit before the decimal point. You may have also noticed that the exponent of 7 in this case refers to the number of times that the decimal point was moved. So when we started this problem, the decimal was at the end. But when we ended it, it was between the 4 and the 5. So if I were to count how many times I moved it, 1, 2, 3, 4, 5, 6, 7, that is the same as the exponent in my power of 10. Scientific notation can also be used to abbreviate numbers that are really small. So the mass of planet Pluto is 0.0022 times the mass of the Earth. So since this is a really small number and we don't want to write those zeros all the time, we can rewrite this number using scientific notation. So let's look at how this number was rewritten as scientific notation. Again, pause the video and make some observations about how we turn this small number into scientific notation. Okay, let's look at this. You might have noticed that once again, there's still only one digit in front of the decimal point because the rules don't change if I'm working with really big numbers or really small numbers. And here you're looking at a -3 as your exponent. And we know that -3 is actually like multiplying by a fraction, 1 over 10 to the third, or 1 over 1,000. And if I'm multiplying by a fraction, what usually happens to the other factor? That's right, it gets smaller. So this makes sense that we're using a negative exponent because look, my factor in my first factor written in scientific notation is actually bigger than the actual number. So let's look at what happens to the decimal. You might have noticed that once again, it was moved 3 times. So since I'm taking a small number and I've made it bigger here, I need to turn it back into a smaller number by actually dividing by a power of 10 or multiplying by a power of 10 to the negative exponent. So 3 moves to the left are going to, when I multiply by the -3, I'm going to actually take this factor here and move it 3 moves to the left. So the exponent is negative because I'm multiplying actually by 1 over 1,000 or 1,000th. And so that'll move the decimal in my first factor here 3 times to the left to make it smaller. So let's do some practice. Go ahead and determine the exponent you would use in each of these problems. Pause the video, then press play again. Okay, let's check your work. Number 1, you should have written 10 to the third. Number 2, 10 to the sixth. Number 3, I'm starting with a smaller number. So my exponent's going smaller than 10, smaller than 1. My exponent is going to be -2. And for number 4, the exponent is going to be -4 because the decimal needs to be moved here 1, 2, 3, 4 places. Let's write each of these numbers in standard form. 10 to the 5th should be written as a 1 with 5 zeros. 10 to the 8th is a 1 with 8 zeros. 10 to the -4, I would have to take my decimal, which is at the end of the 10 here, and move it 4 places to the left to get 1/10,000th. And 10 to the -6, I'd have 0.000001 because I had to move the decimal 6 places to the left. Now, one last time, pause the video and answer or write each of these numbers in standard form. We are done with this video. You can go ahead and watch any parts of this video as many times as you need to, but don't forget to WSQ in your notes.